Grade 9 Physics, Chapter Work and Energy, Module 4. Objectives: to define power, to find the relationship between kilowatt hour and joule, to state the law of conservation of energy. Power. Suppose an old man takes 10 minutes to do a particular work, whereas a young man takes only 5 minutes to do the same work. It is obvious that the rate of doing work of the young man is more than that of the old man. So, we can say that the power of young man is more than that of the old man. Thus, power is defined as the rate of doing work. We can obtain power by dividing the work done by time taken. P is equal to W by T. In other words, power is the work done per unit time. When work is done, an equal amount of energy is consumed. Power is also defined as the rate at which energy is consumed. Power is equal to energy consumed by time taken, or P is equal to E by T. Power is a scalar quantity. Units of power. Power is obtained by dividing work done by time taken to do the work. Now, work is measured in the unit of joule and the time is measured in the unit of second. So, the unit of power is joules per second. The SI unit of power is watt. 1 watt is the power of an appliance which does work at the rate of 1 joule per second. That is, 1 watt is equal to 1 joule by 1 second. 1 watt is equal to 1 J by 1 S. Watt is a small unit of work. Sometimes bigger units of power called kilowatt and megawatt are also used. 1 kilowatt is equal to 1000 watts and 1 megawatt is equal to 10 lakhs watts. Now let us do a problem. What is the power of a pump which takes 10 seconds to lift 100 kg of water to a water tank situated at a height of 20 meter? Given G is equal to 10 meter per second square. We have W is equal to mgh, M is equal to 100 kg and G is equal to 10 meter per second square. H is equal to 20 meter. So by substituting the values in the above formula, W equals 100 into 10 into 20. W equals 20,000 joules. T is equal to 10 seconds. So power is equal to W by T. We already have got W equals 20,000 joules. So by dividing 20,000 by 10, we will get the power as 2000 watts, which is also written as 2 kilowatts. Now, commercial unit of energy. The commercial unit of energy is kilowatt hour. The SI unit of electrical energy is joule. 1 kilowatt hour is the amount of electrical energy consumed when an electrical appliance having a power rating of 1 kilowatt is used for 1 hour. Relation between kilowatt hour and joule. 1 kilowatt hour is equal to 1 kilowatt for 1 hour. 1 kilowatt hour is equal to 1000 watts for 1 hour. But 1 watt is equal to 1 joule by 1 second. That is, 1 kilowatt hour is equal to 1000 joules per second for 1 hour. We know that 1 hour is equal to 60 into 60 seconds. That is, 1 kilowatt hour is equal to 1000 joules per second into 60 into 60 seconds. That is, 1 kilowatt hour is equal to 36 lakhs joules. That is, 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules of electrical energy. It should be noted that watt or kilowatt is the unit of electrical power but kilowatt hour is the unit of electrical energy. 1 kilowatt hour of electrical energy is commonly known as 1 unit of electricity. Transformation of energy. The change of one form of energy into another form of energy is known as transformation of energy. When a body is released from a height, then the potential energy of the body is gradually transformed into kinetic energy. Here you can see some of the energy transformation. The chemical energy of a battery or a cell is transformed into light energy. Chemical energy from the food can be transformed into mechanical energy of the body. The electrical energy can be converted into heat energy. Just like the chemical energy can be converted into mechanical energy of a car, electrical energy can be converted into light energy. And the light energy, the radiant energy from the sun, can be transformed into chemical energy. Here you can see the energy transformation taking place in a hydropower plant. The potential energy of the water be transformed into kinetic energy of the falling water as well as the turbines. Then this rotating turbines produces electrical energy. Some amount of energy be changed into heat and sound energies. Law of conservation of energy. According to the law of conservation of energy, whenever energy changes from one form to another, the total amount of energy remains constant, or energy can neither be created nor destroyed. During the conversion of energy from one form to another, some energy may be wasted. Although some energy may be wasted during conversion, but the total energy of the system remains the same. In this module, you have learned about power, commercial unit of electrical energy, and law of conservation of energy.